Thank you, Professor Ito. It was really an quite engaging talk. Moving to the
Thank you.
Q&A session. Yeah. Uh,
Mhm.
the first question, what is the maximum volume of the reactor in ball milling machine? Is scale-up
Sorry,
synthesis possible?
excuse me. Again, please.
Uh, so what is the maximum volume of the reactor in the ball
Ah,
milling machine? Yeah.
yeah, so they are depending on the just some jar. So we have maybe smallest one is 1.5 milliliter, and the usual some maybe just screening research we just use a 5 milliliter or 10 milliliters. We also have 100 milliliter, and we also have kilogram ball milling jar. So and in the literature, of course, maybe ball milling is very popular for just a mining company. And they have, for example, tons or several tons for ball milling. But maybe we can conduct kilogram scale and we can repeat such scales because in many cases, uh, reaction uh, reaction time can be very shorter compared to some solution phase reactions.
Right.
So that's, for example, we can repeat 1 kilogram scales for example, 10 times or 20 times. We can scaling up just repeating such ball milling reactions.
Right. Yeah. Thank you. Thank you for the response. Moving to the next question. In the coupling reactions of highly insoluble solid aryl halides,
Mhm.
heat gun assisted ball milling at temperatures exceeding 100 degrees Celsius is often necessary. Under such conditions, do the reactions melt prior to the reaction? If so,
Okay, yeah.
yeah,
Some maybe reaction temperature is much lower than their melting points. So we also check some melting relations, melting points and the reaction temperature. Some many cases, so reaction occur very lower than at the temperature very low, much lower than some melting points. Maybe
right,
some temperature effect is I think two factors. One factor is just maybe adding some activation energy for reactions. Another one is a morphology of some substrates. Some solid material can be a little bit softened by adding some heating. That's a second factor.
right. Thank you. Moving to the next question. In any case, mechanochemistry is done without dissolving. So why do the more insoluble materials require harsher conditions?
For more insoluble materials. We check some insoluble compounds that solubility is 10, 100 times less compared to carbon 60. That works. But we don't know some more insoluble compound. But we also use polymers. For some polymer transformation, we also maybe tried, but sometimes that works. So one practical problem for research is it's not easy to find insoluble materials. So maybe of course many people suffers from insolubility. But if we want to make, for example, if we want to purchase some insoluble pure materials, it's not easy to find. Pigments is also one possibility, but I don't know. This is some limitation of research.
Right.
I believe that many insoluble material can be used for synthesis by using volume.
Mm,
We need
yeah. Thank you. Moving to the next
second.
question. Okay. Yeah. How do you handle safety considerations in ball milling reactions, and what is their significance in mechanochemical processes?
Okay, that's a very important point.
Yeah.
So we just start some maybe new revolution using mechanochemistry. We are now just a stage for maybe checking some safety concern about that. So for small scale so far, we don't find any very dangerous thing. For example, one millimole, 2 millimole, 10 millimole, that's okay. But in a really more larger scales, we sometimes find maybe kind of heating of little bit some heating problem of reaction conditions. So in that case, we need to be more careful about this. But one advantageous point is we don't use so much amount of solvent. So in case of maybe such some superheating of the reactions, some problem is some in the solution case, some problem was maybe to refluxing to boiling of some solvent is a very big problem. But in our ball milling case, some boiling maybe solvent amount of solvent much less. Some boiling is not super critical. That's a little bit. My impression is a little bit safer than some solution phase reactions. But we need to some more careful about safety concerns. We need to be more careful, especially for more large scales. We are trying to make some maybe checkpoint or guideline in future for some scaling up for mechanochemistry.
Right. Thank you. Moving to the next question. Can mechanochemistry deliver the same results for organic reactions whose selectivity or reactivity is dependent on the polarization or stabilization effects of solvents?
Okay, so of course that depends on the reactions. So for example, enantiomer selective reaction is very delicate and the solvent effect is very important. And sometimes maybe solvent can can improve some reactivity and of course selectivity. In that case, so sometimes mechanochemistry causes some decreasing of selectivity. Some for enantiomer selective reaction, we are just maybe we just trying to find a good catalyst that can show some better selectivity compared to the solution state. So now we are doing this. So, but in general, some if some reaction shows a very requires shows a very high solvent effect, we need to be very careful to control some selectivity.
Right.
In some cases, some selectivity are almost same.
Thank you. We have a lot of questions still coming, but for the restriction of time, we will take one more question.
Yeah.
How does the nature of solid compounds, that is powder, fine particles, etc., affect the reaction yield and rate?
You mean some effect of the particle size of the reactions?
Yes, yes.
So yeah, we also tested, but for organic compounds can be very fine powder just after the 1 minute or 2 minutes of the ball milling. We compare start from very fine powder and just maybe solid of starting materials, but results are not so different.
Okay.
Because some ball milling machine is enough powerful for making powders.
All right. Thank you so much, Professor Ito.